Okay, so quadratic formula is just this piece. So I've got 1, 0 here, x equals negative 3. Then I'm going to use quadratic formula. So I'm going to do negative b, which is negative negative 3, or 3, plus or minus the square root of b squared, so negative 3 squared minus 4, a is 1, c is 9. And then all over 2a, which is just going to be 2. So let's simplify. Negative 3 squared is going to give me 9. Minus 36, I'm going to, so this should all be x equals to this. X equals, I'm going to do that in one step. 3 plus or minus the square root of 9 minus 36 is negative 27. Uh-oh. So we get a negative inside of the square root. So we have to remember that this can be simplified as 3 plus or minus all over 2 plus or minus here. 27 becomes, I can bring out a 9, which is the square root of 9 is 3. I can bring out the negative 1, which is an I. And I'm left with the square root of 3. So my other two zeros here are not real zeros, they're complex. But I have x equals negative 3 and 3 plus or minus 3i square root of 3 all over 2. Okay, next one. 9x to the fourth minus 27x squared plus 20. Okay, so we're back to these trinomials. If we have a trinomial, is it a perfect square? If so, let's write it that way. If not, we have to try and factor it. So 9x to the fourth would be a perfect square, but 20 would not. So we need to look and find what can multiply to give us 9 times 20, which is 180, and add to give me negative 27. So we have done this many times, and we would take the 180 and try and break it down into factors. I know that I have to add to get up to negative 27, so I've got to pick some numbers that are going to do that. So what if 180 is divisible by 15? And if you can't guess right the first time, then make yourself a prime factor tree and try multiplying some things together. But 180 divided by 15, magically, because I told you the answer, works out to being 12. If not, you would maybe divide it by 10 and 18 and say, well, that's close but not quite, so you've got to try and come up with some other factor combinations. But this works. So we are going to do bottoms up, which means we're going to ignore this 9 for the moment, and then we're going to do x minus 15 and x minus 12. But then, oh wait a minute, excuse me. We're going to make this x squared and x squared. And then to consider this original a here, we're going to divide, oops, maybe if it'll let me. We're going to divide by 9 and do simplifying if we can. But we're going to solve this for 0. So we're going to say, so this works for what we need right now. So we can split this up and say that x squared minus 15 over 9 equals 0. And, hold on one second. Excuse me. Okay, Google, stop timer. And x equals, oh no, x minus 12 over 9 equals 0. X squared, 12 over 9. Okay, so we can solve. X squared equals 15 over 9, which is positive, thankfully. And we would take the square root of both sides and get that x equals plus or minus. The square root of 15 is not reducible, so we just leave the square root of 15 and we put it over the square root of 9, which is 3. So here's 2 of my answers. Then x squared equals 12 over 9, because I can add that to that side. Square root, and I do have to do some simplifying here. X equals 12 is 4 times 3. So the square root of 4 is 2, plus or minus 2, square root of 3 over square root of 9, which is 3. So hopefully you can read that. But it says the square root of 12 over 9 will be plus or minus 2 square root of 3 over 3.